Hello.
Hey, Mark Anton, I'm just getting ready.
There's only two of us now. Let's see who comes. Felix can't, but I expect him to come if I remember well.
Right. Hello.
Hi, Tim. How are you?
All right. Busy.
Yes, I hear you. I'm looking at how I will present this. Technically, that is presentation. Part. No, I thought I want. Yeah. Yeah. Let's get started. I think. Okay. Further existential graphs. We were pretty much. Right? You were there?
Looks right, yeah.
So what's really interesting, we spoke a lot about negation in our system, and to the logic of existential graphs, I think that's also Peirce. And what's interesting about existential Peirce is that they use negation for conditionals in an interesting way. I mean, up to a point, it's classic predicate logic, but it works well with quantifiers. So we have existence as a line. Oval for negation, conjunctions implicit. Sorry, I'll just, no, I'm not doing that right now. Take a break. Okay. So if I say a cat is on the mat, I'm saying there's a relation on. There's the cat and the mat, they're kind of implied to exist because of the dashes. Something is under the mat. I'm not saying what the something is, so it's an empty line. Something exists. So it exists an X such that X under the mat. Some cat is not on the mat, and this is where it gets interesting. There's an X, and negation of, there's an X which is a cat, and it's and it's not true that cat on mat. The negation here includes the predicate. Some cat is on something which is not a mat. So again, the on is asserted, the mat is negated. So it's, oh, and he has whole presentations about existential graphs and how you can do conditionals from that. And well, I think we'll get there in this. CLIP is very much predicate logic inspired. Exists X, negation, relation, and Lispish notation. And predication as also Lispish notation. So it exists XY such that X is catness of X on XY and madness of Y. And all those same examples, and we see where the negation applies to that existential graph notation, except it's text. But these are claims described as predicates and negation and variables. And I think most predicate logic, that's what predicate logic is. And that's first order predicate logic, because you can predicate over entities. You have variables to say, oh, by the way, this X here is the same as this X there. And it's the variable identity that gives you the connection between the various parts of the claim. Classic, classic, classic. But again, let's look at the classics. Existential graph without notation. So a line of identity states that something exists. In CLIP, this exists X, and relation in CLIP are represented as identity of variables. That's what I was saying. And in existential graph, you have the line. There is something, I think that's all pretty clear. I want to gloss over that. Exist X, which is a man, and some man is a king. Exist X, which is a man. How is that not the same? How is that different from this? I'm trying to see the symmetric. Exist X king, some king is a man. Yeah, both of them would imply that, but the other way may not. Yeah, it seems to me that's ways. Anyway, one of Peirce's example. This is more again. There's Ricalso was claimed that whenever you have a logic statement, there has to be a linguistic translation. So here's the linguistic form. There's a Sagerai, blah blah blah, who teaches Macedonian, and here's the CLIP version. So that's the Peirce existential graph notation. That's pure English, and that's CLIP, which is a form of propositional calculus. Without negation, CLIP can represent the content of a relational database or the graph databases of the semantic web. Yeah, semantic web is bad at negation. It's harder than it looks. Now, when we introduce negation, this is where it gets interesting. Where we put the boundary of the negation matters. If we put it against, there exists a man, so there does not exist a man. If we put it, something exists which is not a man. And here we have the line saying there is this entity which exists, is a king, and is not a man, which is interesting. Okay, that's pretty clear, but worth reading. one line of identity. This is about the notation. In CLIP, a shaded oval is represented by a tilde and square brackets. So the equivalence of that, so it's not true that there exists a X and man. And there's, of course, an identity that makes that equivalent to for all X is not a man. There exists X such as X is not a man. So here the tilde, the oval does not include the existence, but includes the predicate. Exist X such that X is a king and not a man, or I think those two are equivalent more and more. Now this is where it gets really interesting, nested ovals. These are three linguistic translations of the same statement. Double negation is positive, so evenly nested areas are positive. And a nest of two ovals represent an if-then statement. So if there is a man, now this is negated, meaning we don't know that. But if there's a man, then he is a king. Or in other words, there's no case of a man who is not a king. I think that's better expressed here. I mean, this would be the original statement. There's no man who is not a king. So there is no man, there is no man who is not a king, but because double negation, we get this positive. In other words, if there's a man, he's a king, or in other words, every man is a king. So a nest of two oval alternate statement with two or more negations, an extensional graph may be translated to CLIP again. It's same principle. Not exists X such that man X and not king X. So that's the same diagram. In this. Seen this king man here. And basically this is putting a novel. We've used that example. It's putting a novel around the whole thing. And then these are CLIP notations of each of those English sentences, but they happen to have the same diagram and they happen to be logically equivalent. So that's a very neat way to do negation in diagram form. If we look at functions, we spoke about functions at some point. The fourth function may be named, and this is a direct mapping. There's exists such that U, W, Y. So here it's assignment. And X, Y, where's the Y? Equals Y, yeah, okay. So this is, again, it's interesting that it's exist X, Y real. I'm a bit puzzled by that because this is a function, it's for every X, there is a unique Y. But anyway, let's not, that's one way certainly to represent the function. Quantifying. Okay, that's very interesting. The last point. The first is pretty obvious. It allows quantifying names to refer to functions and relations. Bobbins who are related. So here there exists R, which is a familial relation between bobbins. So you're allowed to have quantifiers over predicates in CLIP. And here, the last note is interesting. Higher order logic with a hierarchy of infinite sets is extremely inefficient for computer processing, but common logic uses a version of second order logic. That is, you're allowed to quantify not only over individuals, but also predicates. That is as efficient as first order logic, which I find fascinating. I'd be curious to know the algorithms behind that. But that's the claim here. Ligatures. So it's a way to do identity. So you're basically you have two diagrams and you're creating identity. I'm curious about translating this into language. If there's a God, it's God. Kind is yes. There exists a God, and if there exists another God, then it has to be the same, basically. Okay, so yeah, no. I was not familiar with that ligature thing. An e.g. ligature or clip identity may relate multiple names. So basically, this is the all same as. Nice. So it's a way to relate different names. Informal mappings to natural language are okay for humans. Informal mappings to RDF and all are okay for simple knowledge graphs. But anything computer does is formal, of course.
Sorry, there's something I don't understand about this ligatures thing, and it's the negation, including with the. First of all, what's the ligature? Is that what is it? Oh, it's the dot.
It's the dot.
Okay, and so why do we have to include? And like the first example, so I see if I look at the left, there's a line with no ligature and a negation circle. Yeah. Not sure what that is. And then the ligation appears, or ligature, and then there's the example of like there is only one God, I think is what that's supposed to stand for. I'm not sure about that. So why start with the negation? What does that straight line even mean? Is that supposed to be two things?
Yeah, that's the straight line is probably one thing. So I'm really a bit suspicious of the first diagram. I think it's just you can draw an oval anywhere, but it's a bit meaningless in this case because the existence is outside the oval. So this X exists. Here we have, there's an X and the Y, and they're not the same. So here we're saying putting the ligature inside the shaded area means the equality is false. X and Y are not the same. Yeah, there exists X and Y, and they're different. So that's the middle. To emphasize the ligature, the EG in the middle has an optional dot on the connection. So the dot is optional. So that's interesting. So actually this and this are equivalent, and I did not see that. I thought this was one line, but because it's entering the oval from different points, it's considered two lines. Okay, I stand corrected.
Okay.
So it was a perfectly valid question. And yes, I think the dot makes it clearer that we had two names and now we have one.
Okay.
Discourse representation theory specify a subset of natural languages. Now, I'm not familiar with discourse representation theory, and it's really worth digging into. Discourse representation structure represents full first-order logic. Every DRS is precise mapping to and from clip. Semi-automatic translation of natural language and knowledge graphs to and from clip. NL to clip is error prone. No kidding. Clip to NL is precise but verbose. Human translation depends on the human. Human-aided computer translation is what he's proposing. So that would be worth, again, digging into the state of the art there. But the question is in which direction, right? But I agree totally. Human-aided. I'm not trusting machines with that. Mapping DRS to clip. So DRS, that would be nice. Pierce and Kemp independently choose isomorphic structure, nested ovals versus boxes. They're isomorphic. And both of them can be a theory. Features of predicate calculus do not have direct mapping to and from natural languages. No kidding. Pronouns can cross sentence boundaries, but variables cannot. There's an operator that can relate X and Y in different formula. In English, quantifiers in the if clause govern the then clause. If a farmer, well, yeah, there was this whole debate at some point in the history of logic about if you say, if you have something such as all X or Y, does that mean that there exists an X? What is the meaning of, what's the relationship between universal quantifiers and existential quantifiers? When does negation improve existence? Yada, yada, yada. We take a lot for granted now because we learned a certain way to interpret logic terms, but these were arrived at through negotiation among mathematicians. Even the fact that we tend to think of or as inclusive or as opposed to exclusive or. In natural language, it can be either, and context tells you whether the or exclusive is or inclusive. These were negotiated by mathematicians. This current arrangement is known to be expressive, so that's good. But there's a level of arbitrariness here. And here they're saying CLIP has both options, the if-then option and the predicate option. If then, oh yeah, sorry. If there is a farmer owning a donkey, then he beats it. For all farmers and donkey, if he owns it, he beats it, kind of. Proper names are rarely unique identifiers. Both Kant and Peirce represented names by monadic relations. Yeah, right. Disjunction. So that's really interesting. In existential graph, again, you can use disjunction by using the negation notation. Basically, you're saying it is if nothing, because there's nothing in the shaded oval, then one of those will be true. It's nice that it's that easy to do disjunction using negation. Is, what is the word is? Ha ha ha. It can be existence, it can be predication, or it can be identity. And interestingly, it's very different to do it in CLIP, but in existential graph, it's actually always aligned. There is an X, X is a cat, and X is Y, ligature. EGs are more iconic than predicate calculus. They show relationships clearly and directly, which is absolutely true. They're not. Pedro's a farmer, Pedro owns a donkey, and then you can just connect them, which in predicate calculus is hard, but in existential graph is trivial. And then you know that Pedro is this farmer owning a donkey. The names X, Y, and Z make DRS and CLIP more verbose than existential graphs. Meta-language is language about language, and this is where I'm interested, of course. Knowledge graphs can state information or talk about information. Logic for knowledge graph should also support meta-level knowledge graph. The IKL extension to common logic supports meta-language. So there is meta-language in the IKL extension, and we'll get into that. Meta-comments and CLIP may even be expressed by emojis. Here, how they do it is a non-shaded oval. So this is a claim, and here we're speaking about the claim. So without shading, the existential graph expresses a proposition that is neither asserted nor negated. In CLIP, you would put brackets around the claim. See, there's again more SOA documents on meta-language modality and intentionality. That's all useful. And meta-language, we'll get into that. It's also gets into mental spaces. There's a book called Mental Spaces, by the way, by Foucault, which studies, it's a fascinating book about hypothetical worlds and how we draw inference on hypothetical world. And he gives examples of sentence such as being shown a painting and, oh, if the painter were any good, the person would have blue eyes. So there's this alternate world where the painter is a better painter and the character would look different for color harmony reasons, perhaps. But it's all, so there's this notion that, oh, it's the same painter, but it's different in terms of painter quality, and the same painting, but it's different in terms of the eye color in the painting. So how do we map entities between the actual world and this hypothetical world? He really goes in depth in that fascinating stuff. So here we have 3 interpretations of that drawing, and it's not about interpreting the drawing that's important, but these are things we may want to express. Why in terms of the canonical debate? It's because I think it's important to have information about, this person or this group of person believes X. It's something that may be debated about. So here, actual, Pierre thinks of Mary, Mary thinks of Pierre. Modal, Pierre is thinking of Mary, who may be thinking of him, because that's only in Pierre's hypothetical world. And intentional, Pierre hopes that Mary is thinking of him. So possibility, hope, or actuality. And similarly, 3 ways of relating a proposition to a situation. That's really interesting. The kinds of logic, right? P is true or false. The claim is true or false. The claim is modally true or false, possibly, plausibly, impossibly, and intentionally. So some agent X relates P to S for some reason R. The reason may or may not be known even to the agent.
I mean, that sounds a bit also, well, for some reason would be like because, and that translates in our case usually to making an argument. That's not what they mean by for some reason are here, is it?
I don't think so. I think when you say make an argument, okay, I think we should vaccinate, we should have a vaccine mandate because it would reduce the death toll. Okay, that's a reason, but implicit under there, the real reason is, I think, human life has value and reducing the death toll is good. And that's a value. And that's, I think here it's not very well explained, but I expect when we're speaking about intentionality, we're speaking about goals, values, preference at some level.
Well, but this is relating to language, or a different way to propose something that could be shown in language. Are there examples that wouldn't be making an argument?
Yes, when I'm saying human life is good, is that an argument? It's a statement of value.
Okay, I get it. Although that doesn't sound like intentional. That sounds like
okay. Okay. I don't want to die now. It's a claim. It's we'll assume it's true because I've said it, and it's the reason is purely emotional. I value life more than death. There's no need for a because there. It's about want. I want life. That's just a fact. There's no because. I value being alive over being dead. It's, I want to live. That's, anyway. Where life is good. But it's possible there's also goals. You're right. I mean, I keep bringing it back to evaluation, but it could be, for example, I want to sleep early, so I'm less tired tomorrow. Here, I'm less tired tomorrow. Again, there's an implicit I value not being tired, but there's very much a goal argument. Now, is a goal actual? It's the point is not the actual or modal components which exist in that sentence, right? I think it is true that if I sleep early, I'm less likely to be tired tomorrow. That's a modal interpretation. But the goal interpretation is that I want to be less tired tomorrow, so I will want to sleep early. And that's the intentional aspect. It's beyond the modality. I can be intentionally neutral about modal assessment. You know, I think that, you know, this thing is likely to cause that other thing, and I don't care about either. Or I even care negatively, but I'm saying this is what will happen. There's nothing I can do about it. But I say, oh, we should avoid this, and we should strive to avoid this because it has this negative consequence. That's intentional. So these are a bit, they're not idle distinctions, but the question is, okay, what does it mean to represent those things? And it's true that in natural language, there's often a mix. You're absolutely right there. I don't know if that's what you're saying, but I think it is. So actual claims are just bare clip claims. Modal here, the modal is used as a dyadic relation between the predicate and the situation. So that's how they represent modality. Now, it is interesting that modalities are presented so profoundly differently from actuality. That's the kind of thing that personally bothers me a bit, because actuality is a modality in my mind. Intentionality is a triadic relation. There I'm more comfortable because, you know, we're about an agent and what an agent wants and so on and so on, so forth. So that's different from statements about the world or even perceived world. So preposition are enclosed in brackets without the tilde. So that's prepositions and situations. For every S situation, there exists a piece with that equals P. Describe P. Okay, so here, I think what he's saying, I'm just because I just same preposition and clip. You are a good girl. Where's the wished? We don't know. But yeah. Okay. So basically, when you put brackets around a sentence, you are quoting it about. Okay. So prepositions and pros in brackets without the tilde, that's just a thing. And for every situation, there's P, a preposition, where P describes S. Okay, cool. The keyword situation may be placed inside the bracket to show the intended use. And so they have to say a situation to which this sentence applies. So that becomes an entity. Interesting. So their situations are reified in the system. There's a notion of a situation. Very interesting. Notation for all those situations to which a certain sentence applies. Intended situation. So that's how you would do it. So there's this situation, and you have this, which is a predicate, applies to the situation. Here is the sentences actually, modally. So here we have possible this, and so this is quoted, and the possible modal modifier is applied to this. And here is the intentional version. This person hopes for this situation, which is described by this. IKL does not support modal logic, but meta-language can be used to define modality in terms of laws and facts. Well, that's really interesting. I need to get back into stages ago. And conceptual graphs express the same logic as existential graph. Okay, that's interesting. So here we are going, we're shifting notations. Existential graphs are Peirce's idea. Conceptual graphs are Sowa's idea. So they express the same logic, but they represent some details of natural language. So here we have roles, basically. A predicate, which is a frame, has slots, and those slots are named. And so there are the roles of the slots in the frames. I thought I had stopped this. And so we have, say, instead of saying that the farmer beats the donkey, we're naming the arrow, saying this is the agent, this is the patient. In owns, this is the expression, that's not very clear, and this is the theme. And this can be translated to clip, so though it's getting extremely verbose. Unlike existential graph, quantifiers and conceptual graphs are represented by boxes and not by lines. Yeah, names refer to concept boxes that represent verbs. Yes, the semantic or thematic roles used in linguistics relate verbs to nouns, the experiencer, the theme, the agent, and patient. So this is a frame theory of language. Again, there's many such, but it's about saying in what are the roles of the different complements of the verb. We used to call about subject, object, and direct object, but linguistic got a bit more precise because those vary a lot from language to language, but the conceptual underlying themes that linguistics discovered are who experiences the action, what is the action about, who is doing the action, and who is receiving the action. So these are roles. Why is, yeah.
Yeah, just to pause on this and reflect a little bit on how this applies back to the goal. Just one thing I'm wondering about is like which of these are definitional and which of these are structural, which means if we're looking for a canonical claim and that sort of thing, I think this is attempting to provide a a direct mapping, or
Syntax.
how do you say it? Yeah, a syntax. Well, not just a syntax. The idea is that it's a way to express a concept, right? So it could be expressed multiple ways in a sentence, and yet each expression maps to the same map here. There's no two ways to map something, and I consider that, yeah, well, that's something we'll have to deal with. But then the other question is, which of these are structural, or which things in a sentence are structural, and which things in here require a definition. Like you said, there's yeah.
No,
any entity needs a definition, right? Any entity needs a definition of some sort. Verbs probably do as well, right? Except, well, there's three kinds of is. So maybe that's according to what we reviewed here. So you would want to select which the is or something.
Yes. Well, this is where FrameNet is relevant, by the way. FrameNet does a catalog of verbs abstracted, right? This is this action schema underlying this verb, and there's another verb that can explain the same thing. Where I said more or less is, you're right in a way. There's many natural language sentences can be translated to the same CLIPS sentence, which is isomorphic to conceptual graph, existential graph. Though of course, not purely isomorphic, because, for example, conceptual graph add information to existential graph. I'm a big fan of conceptual graphs. When you said it should map to the same sentence, well, sometimes not. There's isomorphisms, like it's modulo logical equivalence, right? If De Morgan's law, for example, is applied, you get two versions of a given conjunction. And so there's two equivalent CLIPS sentences for a single concept, underlying concept, and that's fine. And this is where we get into normal forms and applying those equivalences towards a normal form, and so on and so forth. But there's not one expression, there's one expression modulo equivalence. But you're right, part of it is about choosing. If we want to be canonical, choosing, okay, what do we mean by beats? And there's many kinds of beating, and this is where the word of frame is relevant. I don't know if you had time to look at it. I've been quoting it a lot. I really want to emphasize how fundamental I think it is. 2 seconds. And my computer is being slow because I hate my computer with passion. If you want to frame it at frame index. Is that what I want? Yes, that's what I want. So here's the index of frame. So aggregate, aiming, blah, 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 amounting to, assessing. So what does assessing mean? Well, you'll have, here are the roles. So the assessor, we have, this is a phenomenon, this is what's core, non-core, and the different roles of things that can go into the assessing frame. So they've tried to catalog what does it mean to avoid? What does it mean to this in terms of, well, there's a situation, there's circumstances, there's an agent, and has to be sentient, has to be this, has to be that, and other stuff you can find there, which is not always there, but makes sense in that frame. So these are the plausible attributes of a given frame. So these have been cataloged. And what is nice is if you look at the, they're now extending this in a multilingual fashion. So that it's not just English verbs, but where there would be mapping between languages saying, well, beat opponent, hello, beating, that's victory. So that's not what you want. It's not the beating the donkey. So there will be another verb, presumably, that has this notion of beating. So it probably cause harm. So that would be the, we have to know that beating, the farmer beats the donkey, falls under the cause harm frame, and the verb, the French verb battre, molester, or all kinds of different verbs in different languages can fall under this frame. And this is what they have in common.
How did they select these words? Because I just was trying to look for basic examples, and I looked for eat or walk. I think I may be misunderstanding what's here, but like why are some words missing? I mean, I know that human beings are creating this, and so they're times limited. But do you know how they prioritized filling the index?
It's not a question of priority. The question is, walking is a good example. The idea is walking, running are probably all fall under a generic term, and I don't know what the generic term would be, but it probably would be something like locomotion or movement. And now there should be a better index telling you, okay, I'm looking for walking. Under what frame does it fall? I'm sure it's possible, but not in this interface. Here's motion. Good. So here's motion, and here's directional motion. That's probably walking towards. But let's say motion. So walking is, here's flying, went. I'm sure there's example about walking in there, or if there isn't, there should be. Drifted, moved, blew, floated. Here's lexical unit. Here's lexical units. And I don't know why walking is not there. So that's really interesting. But I'm sure there's a way to search the lexical units and say, okay, what frame does it fall onto? But the point is, it's not supposed to have all the verbs on the left column. The left column is it's the cluster names.
Mm-hmm. Okay, that makes sense. Thanks.
Now, how they choose the clusters, that's their, I don't know the details of the methodology. Perfectly valid.
And then now I'm looking at, I guess, what's an FE, a frame element, or the variables. If you go up to the colored, things.
Yeah. Notion of area, of distance, of goal, and so on. Yes.
Do you know what FE stands for?
FV, where?
FE. It's right above that. So Frank Echo.
Oh, frame
FEs.
elements. Frame elements.
Frame elements. And then do they match frame elements between frames? So like, do they have some concept of
the notion
like
of goals?
Area?
Goal should be found in many frames. Distance, this should be found in not so many frames, but in a few. But for example, many, like the theme will be common to a ridiculous number of frames. Source will be common to a great number of frames. The point of frame elements is precisely to abstract the roles so that there's a small number of roles which are common to many frames.
Because one thing I'm not seeing is like a link. If I thought if maybe if I clicked on theme, then it would then have an index of all of the, here's where theme appears as a frame element of these frames.
Yeah, but this is all data available as CSV, SQL, and you could create an interface that has these links. The data is there. The interface is not good enough, but the data is good enough. That's what I'm telling you.
And part of what I'm trying to figure out is the absence of that functionality indicative of the creators of the systems lack of confidence that frame elements across frames should be no. So you think they definitely match up?
Absolutely. No, that is I'm absolutely sure about that. That's interesting. That's basic linguistic theory, and that I know was used to build the system. I know that the theory they used for this requires these frame elements to be common.
Okay, thanks.
This is it doesn't look like much, but there's an enormous theoretical sophistication behind this site. Computer sophistication is another story, but the knowledge of linguistics behind this site is absolutely stellar. So where were we? Back here. Oops. No. Sorry, I'm confused because I had. Oh, there it is. Okay, good. So we were here. So here we're introducing frames. So patient, agent, theme, and so on, and frame roles. So that's an enrichment of existential graphs to have frame roles. And of course, SOA has something on it. And here are propositions and situations. And you can have extremely complex. Some believes that Mary wants to marry a sailor. Is that a hypothetical sailor or a specific existing sailor? And these would be the different, that's an ambiguity in the sentence, which is expressed as two slightly different graphs. Is the sailor inside the hypothetical situation, or is it outside in the quote unquote existential role? So Tom believes that proposition, Mary wants situation to marry the sailor. So this nesting is allows for very sophisticated subjunctive, hypothetical world, belief in somebody else's mental state, that kind of sophistication. And for the third interpretation, the concept box for sailor would be moved to the area of the proposition. Tom believes that there's a sailor who Mary wants to marry. So here, sailor would be here in this box. So these are three valid interpretations of the sentence, and they correspond to different graphs. So three interpretations of Tom's belief. The sailor exists in reality, in the proposition, or in the hypothetical situation that Mary wants. Okay, automated and semi-automated tools. I don't know if, but this was the core of this notion that here's this notation that allows to make these statements, allows for negation, allows to hypothetical, allows for subjunctive. These are the kinds of concepts that are worth. Okay, computers should ask for humans for help because we don't know. Humans are not necessarily good at this. Computers should accept any language or annotation people prefer, and they should read documents without requiring prior annotations. Yeah, those are use case requirements, really. If a computer can't understand some text, it should ask people for help. Computers may annotate texts, but human assistance is necessary when a computer is uncertain about the interpretation. Analogies can support informal case-based reasoning and cognitive memory. You're familiar with translation memory, perhaps. So here it's about having a memory of formalizations. It's a form of translation memory, really. Saying, well, this sentence usually gets translated as this. And formal reasoning is based on disciplined use of analogy. Theorem provers use a kind of analogy called unification. That is very important. So associative memory for large volume of graphs, approximate pattern matching for analogies and metaphors, associative storage. Okay, that's interesting, actually. Associative storage and retrieval of graphs. Okay, those are specific. That, by the way, I think is that the article I said, Tim, you should want to look at. SOA worked with Arun Majumdar. Arun Majumdar worked for a while at Kindi, KYNDI. And Kindi did have a working cognitive memory project where propositions were encoded in this way and had a unique signature. Like they did a lot of what we want to do, except of course it's proprietary. And then there was a dispute at Kindi, and Arun Majumdar left. He now has another company of his own, name escapes me, but it's easy to Google. And he, because of patents, he cannot redo the work he did at Kindi. So now he's doing more statistical and vectorial interpretation of natural language. But he has, Arun Majumdar with SOA has done this, let's give a unique signature to claims as propositional. Those are people who have done the work. So reading the cognitive memory paper is probably interesting and relevant. So that's context. So the login time is obviously a property of that system they had built, using analogies and being able to do pattern matching between different of those patterns. Similar cases, close matches, semantic distance. So it probably was a hybrid of semantic distance, vectorial, machine learning, machine learning and propositional symbolic. Disciplined use of analogy, induction, deduction, abduction. Need I go into that? That's classic. Basically saying those three cognitive memory system. Knowledge graphs for help and explanation, used to support natural language dialogue and explanations. So cognitive memory uses CLIP. So they used CLIP as the storage language, but they also use anything that can be mapped to CLIP. That includes any knowledge graph that use UML or semantic web. So they translated UML semantic web into CLIP, and that's what they probably did the matching on. Tools for CLIP and IKL can support natural language and logic. And again, there's more at this other document. This is interesting because it's a recent SOA presentation, so it links to all these other presentations in which he goes into greater details about a lot of this. I mean, SOA is a treasure trove of information and thought about those topics. This is one presentation, and it certainly doesn't say everything. Integrate. Please, let's do interoperability. Yes. Enable subject matter experts to review, update, and extend their knowledge base with little or no assistance from IT specialists. So basically, let's have UX so that if you're a subject matter specialist, you don't need to learn CLIP and formal logic, but the system will ask you the questions to distinguish between ambiguous alternatives. And that makes a lot of sense. If the system can say, oh, I think this sentence can be this one or that one, well, let's just ask, okay, which one do you think it is? Translate to natural language, ask the question about natural language, and then store the resulting formal. Provide tools that support collaboration, review, and testing by people with different levels of and kinds of expertise. Yes. So these are all this. Whoops. Formal concept analysis. I've often mentioned formal concept analysis. So this is doing a lattice of distinction between concept types. So if you're doing ontology, a lot of people do ontology like a tree, like there's this great abstraction, and then you divide into subconcept and subconcept and subconcept. But in reality, sometimes at a given point, you may divide along many criterion, and they're all valid. So that means at any point, you have distinction among, let me take tree dichotomic keys, for example. I don't know if you've played with a dichotomic key. You're looking at a tree, you want to know which species is it. So The book, you have a book that says, okay, does it have bark? Yes or no? Does it have this? Yes or no? Does it have this? Yes or no? It will ask questions and it becomes a tree of questions that go. But the idea is, in theory, if it were not constrained by the representation constraints of a book, it could ask you a bunch of questions, some of which are, you could not know the answer to one of the questions. It could be like, okay, well, let's ask this other question, and can we find intersection of characteristic that goes down to a species, even if you didn't know the answer to the first question in the tree. But if it's not a tree with a lattice, it becomes possible to attack the narrowing from any angle. This is what formal concept analysis do. Use any distinguisher to get concepts narrower. And that becomes a lattice. Each axis of distinction becomes a node in the lattice. And then you can do better ontologies with that. Are we generating lattice automatically? So now there's, here they use the Rogers thesaurus, very cute, to create a lattice from that knowledge. But basically, the Rogers thesaurus is a lattice. And here's an example of, I don't know if this site still works, that would be interesting, because that means they've looked at the abstraction relation between terms. And that's pretty. That's the last slide. Advice from two logicians and a poet. I think I'll let you read. I like the Whitehead quote. But yeah, that was the an exploration into conceptual graphs by the way of existential graphs and their clip expression. And maybe we should look at IKL next.
Excellent. I have a hard stop now, and my dog's here, so I have to go. But
it's fine. I also have a hardish stop. I think it is a good stop. But I think maybe we should discuss on the chat what's the next thing we want to do in this exploration of formal systems. But I think.
Yeah, what was your recommendation? IKL.
IKL is a possibility deeper under that particular rabbit hole. I did say we could look at psych. Certainly discuss it. I think one thing we could do, by the way, next Friday, I'm not there. So what I suggest you do is forget me and watch the presentation of psych by Linnet next Friday without me. And let's discuss it next Friday and choose another step. I am very tempted to get into the Mathema stuff, but that may be a wrong turn because it's really abstract. On the other hand, it's really interesting. I don't know. I think let's, next Tuesday I'll be there. Maybe we can just take a few seconds to discuss next steps. But I think you viewing Linnet without me Friday is a very good use of your time.
What are you really excited to get into?
The article, the blog post on Tadane Bradley's work on category theory. But that's very advanced. It's very advanced math, and which I don't understand fully. I'll be absolutely candid about this.
Right.
But I understand it just enough to get something out of it. Let's put it this way, to get a feel out of it. And it's fascinating. And it's a good view into the non-symbolic approach to natural language and how it connects to the symbolic approach.
Yeah, that's what I was kind of getting from the introduction she gave too. And I'm nervous about approaches that tend to be largely editorial, but interesting thing about at least the way she's presenting the paper and these blog posts is that she's talking about this is how you connect the natural language through a large language model to the, I don't know, algebra that's represented of the language.
Yeah. No, she's ultra smart, and the group around her. I mean, she's just very good at expressing it, and there's a lot of research in that area and help understand it. I don't think this is where we're going, by the way.
We being CDL.
Yeah.
And what do you mean by here? Or where are we not going?
I think that machine learning fuzzy equivalence representation based on vector representation of words are very interesting for finding similarity, but they're not that useful for canonicality. I'm very, and I think it's out of scope. It's somebody else's research. It's fascinating, it's useful, it's valuable, but I don't think this is necessary for our use cases. I could be wrong, but our use case is finding, as I understand them, is finding equivalent statements and like, did you already say this? And yes, certainly the neighborhood relationships are useful there, and let's reuse what exists, but creating a new neighborhood view, I don't think is in scope. Using existing neighborhood views, maybe.
Yeah, see, and my take on it is that, I think, I don't know, there may be sort of two, feelings to approaching the system. And one feeling is we're going to have a group of collaborators. We're going to have, a engaged audience of crowdsourcers who are, have different opinions, but are largely, cooperative. And we're going to have sort of a, oligarchy of, whether it's, just because people who are involved early, or whether people are voted in, or they get permission somehow, we're going to have some oligarchy of, editors curating over the top, and that's going to, kind of work, kind of like Wikipedia is working now. And then I think there's sort of another feeling, which is that we don't know, just how cooperative people may be. I mean, they want to engage in a system that, allows debate mapping, argument mapping. They want to connect it to things online, perhaps. Maybe I'm more interested in that than maybe some others like Tim. But we're not really sure just whether they can come to an agreement on, yeah, I agree to this canonical form of the debate. Just because, I mean, sometimes arguments over words are so heated. Someone just may never agree to call it, pro-life. They have to talk about in terms of, like anti-choice or something, like just the words that are selected.
It's a very good example.
So
it's a very good
I'm
example.
I'm nervous that any system that's kind of like, based upon, yes, we can come to an agreement over, how we're going to talk about it. If the system's success is predicated on that, I'm nervous that it won't be able to encompass people who just can't agree on the words ultimately, and they kind of have to, talk about it in their own way. But the system wants to, connect, maybe even to some degree mesh, these conversations in a way, and which I think the statistical approach maybe is good for.
Oh, interesting. Okay, two things. First, I agree totally that getting people to agree on a single term may be counterproductive. And
sorry, just 1 second. My fiance is
almost done. Brenda will call in a second. Okay.
Sorry, I'm back now.
I'm also getting a phone call any second, but this is important. First, I agree that getting people to agree on words is counterproductive, and we need to be able to do mappings across
it's
different
super productive,
vocabularies.
but it's hard. Yeah, it's hard. I mean, it'd be awesome if they could.
It's awesome if they could, but I expect people to stick to their words, and I want to be able to map arguments across vocabularies. For me, that's an explicit goal. First. Second, in a way, the fact that we want humans to be involved is one reason I'm not so big on statistical approaches, except as suggestions to humans. But ultimately, I want humans to resolve, this is the same, this is not the same, this is a subtype, this is an alternate phrasing, blah, blah, blah. Because I only trust humans to do that. And I don't even trust humans, but I mean, I don't trust the statistics to do it. And that means there has to be a representation in the system that is non-statistical, because that's the only thing humans can ultimately check and manipulate. Now, it can be based on asking these natural questions that will create a formal representation, and we can use statistical representations to suggest things to human. I'm all for that, but there has to be a human manipulatable non-statistical representation so that people can argue about something that they can understand.
I agree with that. Yeah, like the machine should support the people's judgment ultimately.
Yes.
Yeah, I would agree with that. And I think maybe now what I'm seeing, maybe
hard stop.
Oh, hard stop. Okay, all right.
Finish it. Finish your.
I was just gonna say, I think maybe then what I'm sort of pushing for is the ability to allow alternate, canonicalities that can be related through the system. Because I'm just nervous that if there's a single canonicality and that people just can't agree on what the word is that fits in this concept, like that, it's just going to break down. Whereas if the people can have their sort of
that is a core goal for me. That is a core goal for me. Unifying across vocabularies and across worldviews, and is a key. Actually, the core goal for me.
Yeah. Okay. Cool. All right. Thanks, Marc-Antoine. Have a great weekend.
Thanks,
Bye.
Bye.